Hello and welcome to the podcast on lead-acid batteries by Ramesh Natarajan. With industry experience of over 42 years, Ramesh helps battery and battery-related industries with technical inputs and provides solutions to typical problems faced by manufacturers, service personnel, as well as users of batteries and related equipments.
Hello and welcome to this episode of my podcast. In this episode, I will discuss a very important aspect of battery design and testing. Please note that the subject of this episode may seem to be different compared to my earlier episodes. This episode is important and very useful, though it may not be very easy to understand. The episode shall also answer a lot of questions that battery manufacturers address to me on the ratio of positive and negative active material that has to be ideally used for cell manufacture. I shall discuss the use of cadmium as a neutral electrode in this episode. Cadmium is a metallic element that has a resemblance to zinc. Cadmium is inherently hazardous and is classified as one of the metals that have a significant impact on public health. Cadmium serves as a neutral electrode to identify the cause of failure in a lead-acid battery cell. It specifically indicates whether the failure of the battery is due to positive active material, negative active material, or electrolyte deficiency. In the design of lead-acid batteries, cadmium is employed to identify the specific electrode that is causing the battery to underperform during the last stages of discharge. Occasionally, it is noticed that both the positive and negative electrodes contain an adequate amount of active material, but there is a lack of electrolyte. Electrolyte deprivation is the cause of discharge termination in such instances. In such a circumstance, the battery designer focuses on optimizing the specific gravity of the electrolyte or increases the volume of the electrolyte if it is possible. The voltage readings of the cadmium electrode also function as indicators during the plate formation process. They indicate the state of charge for each set of positive and negative plates. When batteries are made using unformed positive and negative plates, voltage measurements of the cadmium electrode are done to develop the standard operating procedures for production. Hence, it is evident that cadmium electrodes serve a valuable purpose in gathering and examining charge-related and discharge-related data. The cadmium electrode resembles a cylindrical pencil with a diameter of roughly 10 mm. Typically, the length used ranges from 10 to 15 centimeters. Before usage, it is necessary to immerse the electrode in sulfuric acid with a specific gravity that matches the specific gravity of the battery for a duration of 1 to 2 days. After the cadmium rod is prepared, it can be securely attached to a brass holder. This holder is designed to facilitate the measurement of both the overall cell voltage and the voltage of the cadmium electrode with respect to that particular set of plates. A flexible wire from a voltmeter or digital multimeter which displays the voltage is securely attached to this brass holder. A separate brass holder is used to connect another flexible wire from the voltmeter or digital multimeter which indicates the voltage. This brass holder is designed differently and it cannot hold the cadmium electrode. It is essential to insulate the cadmium electrode to keep it from coming into contact with the cell's plates or the plates in the forming jars while we are taking the readings. It is crucial to guarantee that the cell's electrolyte may freely reach the cadmium electrode. This can be achieved by using a thick insulator with holes or by making sure that the tips are sufficiently exposed. Please note that the measurements are conducted only during the passage of electric current, either during the charging or discharging process. Measurements of open circuit voltage are devoid of significance and they lack any practical utility. To prevent polarization, it is recommended to moisten the cadmium electrode by submerging it in electrolyte for approximately an hour before using it if the rod has dried out. The presence of metallic contaminants in the electrolyte can result in inaccurate outcomes. So we must take care to see that the electrolyte in which it is dipped is not having any contaminant. It is therefore recommended to verify the readings by measuring the overall voltage of the cell. The total cell voltage is determined by the algebraic difference between the potential of the positive plate with respect to cadmium and the potential of the negative plate with respect to cadmium. A lead acid battery consists of many cells of identical capacity and similar structure which are connected in a series configuration. The battery's voltage depends on the voltage of its constituent cells. The cell voltages can vary slightly based on factors such as the amount and ratio of active material, the state of charge, the volume of electrolyte, the specific gravity of electrolyte, and the internal resistance of that particular cell. Let us now examine an example to comprehend how battery designers utilize the cadmium electrode to collect information. Please listen carefully and I hope I am able to convey this part to you in an understandable manner. When measuring the voltage of 3 cells using a cadmium electrode during discharge, if the total cell cutoff voltage per cell is 1.80 volts, we may have a situation towards the end of discharge with 3 cells exhibiting different values. Let's consider cell 1, which consists of a set of positively charged plates with a voltage of 2.10 volts and a set of negatively charged plates with a voltage of 0.30 volts. The difference between 2.10 volts and 0.30 volts is 1.80 volts. Based on the above readings, we can infer that the negative plate group has experienced failure before the positive plate group reached its maximum capacity. In this case, the negative plates have stopped the discharge, which is unwanted and unusual. Now let's analyze the measurements of cell 2. It consists of a set of plates with a positive charge at 1.95 volts and a set of negative plates with a negative charge at 0.15 volts. If the cell has achieved the necessary capacity before reaching the 1.80 cutoff voltage, we can consider the balance of active materials to be satisfactory. However, if the cell fails to meet the capacity test, it is necessary to note that the positive plates in the group are lacking in capacity. The active materials in the positive plates must be reviewed and increased. Next, we will observe the conduct of cell number 3. When the positive plate groups have a reading of 2.00 volts and the negative plate groups have a reading of 0.20 volts, while the cutoff voltage is set at 1.80 volts, it suggests that the cell 3 is functioning normally and it has a proper distribution of active lead materials. If this cell 3 constructed with proper amount of active material fails during the capacity test, the cause of the failure is clearly due to lack of enough electrolyte. The specific gravity at the end of discharge functions as a valuable indicator. A low specific gravity towards the end of discharge may be the reason for cell number 3 not giving the required capacity. This can be readily identified as the reason by an experienced battery testing specialist. To confirm that electrolyte starvation is cause of this cell's failure in the capacity test, one should remove the group from the cell container, place it in a larger container, and thereby increase the volume of electrolyte. The capacity test performed with the same plate groups in a larger container with more electrolyte may solve the problem. I strongly recommend that laboratory technicians and battery design personnel must not base their conclusions only on the plate voltage values which have been noted during the last stages of discharge. It is necessary for them to take regular measurements throughout the discharge phase when designing or testing a battery. Let me now explain the behavior and correlation of plate voltages with respect to the cadmium electrode during the charging process. During the charging process, the potential of the negative electrode undergoes a reversal towards the end of the charge. For a charged cell with a total voltage of 2.70 volts, the positive plate potential is 2.50 volts and the negative plate potential is minus 0.20 volts. The difference is the subtraction of minus 0.20 volts from 2.50 volts. So you have 2.50 minus of minus 0.20, which results in a total voltage of 2.70 volts. Over a period of time, as the cells age, the negative potential does not reverse, resulting in the overall voltage of the cells not exceeding 2.70 volts when charged. Cadmium is the predominant and extensively used electrode in the lead acid battery industry. There are, however, certain disadvantages associated with this electrode. Hence, it is important to carefully evaluate certain inferences that we base on the cadmium readings. A high temperature results in a decrease in voltage across the negative and cadmium electrodes. Therefore, an increase in temperature impacts the final cadmium values indicated during the plate formation process. Next is to ensure the cadmium electrode remains in an optimal condition during extended periods of non-use. It is necessary to clean it and maintain it dry. The presence of metallic impurities, particularly copper, might impact the accuracy of the cadmium readings. Therefore, it is crucial to exercise caution in this regard. Next is cadmium readings should be taken towards the conclusion of formation once the white areas on the surface of the plates have nearly or fully disappeared. It is necessary to maintain the cadmium rods submerged in electrolyte if they are being used regularly. The cadmium readings obtained correspond to the specific charge current used, and it is crucial to recognize and take note of this fact also. I trust that this episode has provided my listeners with a deeper understanding of the significance of testing batteries by using cadmium as a neutral electrode. Thank you very much for tuning in and have a nice day.
Please do visit www.rameshnatrajan.in. Keep yourself updated about our new releases by hitting the subscribe button.